Well, good morning or afternoon, everybody, just like he said just now. Welcome to this little seminar. We're going to talk a little bit about what's new in failover clustering as far as it relates to the latest rollout from Microsoft, Server 2012 R2. I remember it used to be one of these systems that Microsoft used to tell people to always make sure whenever you set up a failover cluster that you have somebody who is considered to be an expert in that field. And since the end of 2003 R2 going up to now, it's become easier and easier to set up failover clustering. And there have actually been some more improvements to the system, especially when it comes to maintenance and keeping the system up and maintaining quorum. And that's what we're going to cover here in this slide deck that I put together for us. This class that this came out of, the Microsoft class that this information is available in, is intended for people who are systems engineers, systems experts, systems administrators, whatever you want to call your position with the company. That if you are working with servers and you're responsible for maintaining high availability, this is what, or this seminar is for you, because we're going to cover what's new with failover clustering. At the end of this, we're going to give you a chance to ask some questions of me. Let me know if there's anything that you want to expand upon further, and if we have time, we'll definitely look into that. Now, New Horizons is putting on this event, this seminar. They are a worldwide training provider. I'm happy to be a regional instructor for New Horizons based here in Nashville, but have several centers underneath my belt. Some information here about New Horizons: 2,100 classrooms with over 2,000 instructors in 56 countries. That's a pretty good foothold on the training market, and we wouldn't get that large if we didn't have very good trainers to assist our students in reaching those levels. And there's several different ways of taking the class. You can take an instructor-led class, whether that's live or over the internet, doesn't matter. That instructor is right there ready to talk to you, ready to assist you anytime you need. There's also virtual delivery through Online Live, like I just mentioned, and also there's some private classes that can be tailored for your particular interests. So if you're not looking for certification and want the full gamut that the class books usually have, you can ask for very specific information that helps you with your business need rather than a testing need. But we can handle either one of those. So I'm going to go ahead and get started on the failover cluster. We only have a short period of time and a lot of information to cover. So we're going to look at implementing and getting failover clustering in place. We're also going to talk about maintenance, maintaining it, what's new with maintenance for failover clusters. And then we'll talk very briefly about multiple sites. If you have multiple Active Directory sites, you have a headquarters site, you have a disaster recovery site, how do we have failover clustering extend from one site to the other when we have to throw in the middle of this the big bad internet, as we like to call it? You ever see these slides? They were always depicting the internet as a cloud, and it was always a bad thing to go through the cloud. It was always mysterious, if you will, going through the cloud. And now we talk about the cloud as being the greatest thing ever, because now we can store things in it, we can move data into it, and we can have all of our functionality living in the cloud. It's a big change from the way it used to be taught, that going through the cloud was not exactly the best thing, but security advances have made it to where it fits the bill. So we're going to talk about that as well. But before we get into that, let's do just a quick little overview of what failover clustering is. We're going to look at the improvements that we have for availability. We're going to talk about the components that make up failover clustering. And then we're going to review what was in 2012 original release. And then we'll talk about what quorum has changed into when it comes to 2012 R2. And we'll talk a little bit about CSVs, or clustered shared volume. Now, whenever we're talking about failover clustering, what we're really talking about is availability. Keeping our systems and services available to the business, business continuity, continuing operation in the event of a failure. That is what we're talking about. Whether your company has a legitimate written SLA that explains out what is offered, what is not offered, what are your metrics, what is the available downtime or unplanned downtime that we have, and what are the penalties for violating those SLAs, and understood that, hey, we're one company. We're all in the same boat. If IT doesn't do its job, the rest of the company can't do its job, and thus everybody suffers, because then the company cuts back and lets people go or outsources things. It doesn't matter if you have one or the other. We're all in the availability game when we're talking about failover clustering. Now, some of the improvements that we've had in 2012 when it first rolled out, there was increased scalability. It used to be that we had a smaller, or what was it, 16 nodes in a cluster. That's what we had in Server 2008 R2. And out of those nodes in the cluster, you could have 1,000 virtual machines in that cluster. Now that has changed. In 2012, they bumped that number fourfold for both. Actually, it's actually higher with the virtual machines. We went up to 64 physical nodes allowed in one cluster, and up to 8,000 virtual machines in that cluster. There's also been improvements to CSVs. This was something that was introduced in Server 2008 R2 and became very popular with virtual machine managers. They wanted to have these CSVs because it worked a lot better than a LUN works. So Server 2012 made improvements to working with CSVs, and now we also support SMB version 3.0. So that allows even more usage out of CSVs. Very little downtime. CSVs have high reliability. They can be scanned and repaired with no offline time. So you do not have to take CSVs down to do most maintenance to them. They also support things like BitLocker. We have another advent called cluster-aware updating. Before cluster-aware updating came along, when you needed to update a server in a cluster, you had to do some preparation. You had to go in and figure out, okay, what services are running on this host? Let me evacuate those hosts to one of the remaining cluster members. I then need to put that server into maintenance mode so that it doesn't fail back or switch back. I do my updates then, reboot the machine, bring it back online, then I have to move everything around again to get to the next machine. Cluster-aware updating is a new technology that updates clusters automatically. It can be kicked off by an administrator, or if you want to, you can have this automated inside the cluster itself. We're going to touch more on that one a little bit later on. We also have some integration improvements with Active Directory. This was started in 2008. Doesn't mean we're going to integrate domain and clusters. That's not what we're talking about here. We're talking about storage of information in Active Directory, such as the configurations of the clusters themselves. And there's also been some management improvements. We still have the same failover cluster management console and pretty much the same administrative techniques there, but there's some managerial improvements. There's improvements done to validate your cluster wizard that you can run. There's also been some changes for tests for CSVs and the Hyper-V role, and checking virtual machines and creating virtual machines from inside the cluster management tool itself. So there's been some improvements there, and whenever you have improvements, of course, you can probably guess there are going to be some changes from previous versions. We no longer have our cluster.exe command line tool for most of the work. It's deprecated. It still has some small functions, but that is about it. You have your MS-CLUS-COM interface. It can be installed if need be, but it is not installed automatically. And the add cluster print server role commandlet's been deprecated because Server 2012 does not support print server role as in the high availability for Server 2012. That is a change you might need to be aware of. Now, this was all Server 2012. When the next version came out, R2 hit the shelves, we had some even more changes, and these were actually more significant changes. We now have a change to how quorum works. We have a new quorum model called dynamic quorum. Dynamic quorum feature allows a cluster to recalculate quorum on the fly. So if a machine fails inside the quorum or inside the cluster, I can still maintain the service even if I drop below 50% of voting nodes with dynamic quorum. There is the opportunity there. Basically, you have a file share witness that has its vote turned on or off as needed. So when I drop below 50% nodes in the cluster, we turn on the dynamic witness, and the dynamic witness then places its vote, which then brings us over our 50% margin in the quorum. We also have what's called forced quorum resiliency. It provides some support and flexibility to manage the split brain syndrome that we run into. And split brain syndrome is when one side of the cluster thinks the other side has failed and thus attempts to continue working with the database. And that runs into a problem, especially when you have multiple sites, where you have a headquarters site and you have a disaster recovery site. If something should happen to the internet connection between them, the disaster recovery site might see that the main site has gone down, when in reality the internet connection is what's gone down, and thus it might try to start servicing requests and working with the database at the DR site. With this one, we can have a way of stopping the model in the event something like that should happen. We get more in that detail a little bit later on. There's also a tiebreaker for 50% vote split. Now, using this feature, the cluster can adjust the running node's vote status automatically to keep the total number odd. Remember, we don't want even numbers in quorum. Even's not good because we got quorum says in order for the service to stay up, we have to have over 50%, not equal to 50%, but over 50%. The only way you're going to get over 50% is when you have an odd number of votes. So that is something new. We also have Global Update Manager mode. The Global Update Manager is responsible for updating the cluster database. In Server 2012, it was not possible to configure how this update works. In 2012 R2, you can configure Global Update Manager updates. So every time the state of a cluster changes, such as when a cluster resource goes offline, all nodes in the cluster have to receive the notification about that event before the Global Update Manager commits the change to the database. So in 2012, the Global Update Manager worked in what we call majority mode. That was a read and write mode. And when it was in that mode, when a change happened to the cluster, a majority of the cluster nodes had to receive and process the update before it was committed to the database. And when the cluster node wants to read the database, the cluster compares the latest timestamp from a majority of the running nodes and uses that data, the one with the latest timestamp, as the data it needed to read. In 2012 R2, well, let me go back. In 2012, we couldn't change that. That was the mode it ran in. In 2012 R2, it also now has a separate mode called All Write and Local Read. And working in this mode, all nodes in the cluster must receive and process the update before it's committed to the database. Not a majority. All of them have to. But when the database is sent a read request, the cluster will read the data from the database copy that is stored locally. Now, because all roles or all nodes receive and process the update, the local cluster data copy is designed to be considered up to date and relevant, since they all have to sign off on it in order for it to be committed. And there actually is a third mode that's in there called majority write and local read, which is the same concept, but we kind of blend the two together. Instead of everybody having to know, we just have to worry about the all, or the majority vote here. We also have some changes in the cluster node health detection. In 2012, the mechanism for node health detection within the cluster declared a node as down if it did not respond to heartbeats in more than 5 seconds, so 5,000 milliseconds. In 2012 R2, specifically if we're talking about a Hyper-V cluster, the default threshold values increased from 5 to 10 seconds if nodes are in the same subnet, and if they are in different subnets, then it goes up to 20 seconds. So that increases the amount of time, especially when we're talking about multiple sites. We're giving a little bit more time for latency for passing in those heartbeat messages. And we also have an option called the Active Directory Detached Cluster. When you create a failover cluster in anything before 2012 R2, it had to create an object in Active Directory for that cluster. So if I called my cluster Cluster 01, a computer object would be created in Active Directory for Cluster 01, and that was where it stored information. In Server 2012 R2, you now have the ability to deploy an Active Directory detached cluster, which does not have any Active Directory dependencies for network name. So when you deploy these clusters, the cluster network name and the names for the cluster roles are registered in the local DNS, but the computer object is never created in Active Directory. You might be saying, that's a great thing, because now I can have things that aren't part of the domain in a cluster. Well, hold on a second. Cluster nodes still have to be joined to the same domain. The person who joins or creates the cluster does not have to have Active Directory create permissions, though. So it does have some side effects with that, because there's no computer object created in Active Directory. You can't use Kerberos authentication when you're trying to access the cluster resource. Network landman is going to become your authentication choice in those kind of clusters. So if you ever have any need for any Kerberos authentication, maybe the services being held on that cluster are Kerberos based, then you probably won't be using Active Directory detached node. Now, the components that make up clusters are pretty much the same. We haven't changed that hardly at all. You still have, like this slide here shows, let me pull out my laser pointer. There we go. Here we have our node 1 and node 2. So this is a 2-node cluster that has been set up. We have our shared data between them, whether that's a storage area network, that is an iSCSI storage device behind it, whether that's a NAS, whatever we want to have. Both nodes in this cluster need to see it. In between the nodes, we have our cluster dedicated network. This is how they pass the heartbeat message. The heartbeat message is, hey, I'm here, hey, I'm here, hey, I'm here, hey, I'm here, basically is what we're saying. And when I miss that, hey, I'm here, something might be wrong. A lot of times we use just, especially if we're in the same data center and even in the same rack, we'll use a crossover cable between the two nodes, if it's just two nodes, for heartbeat information. That way we don't have any kind of switches, routers, or anything in between. We just have one little crossover cable. And then we have a separate network that the clients are going to be using to access the resources that they're trying to get to. Now that hasn't changed, and it's still the same. You do not have to have all three networks. You can have all your the dedicated network for the cluster information, the heartbeat information going across the same network client communication is going across. However, that's not highly recommended because, well, you could get into a situation where there's enough traffic on the wire keeps the nodes from receiving their heartbeat information. But again, in 2012, R2, it's been increased to 10 seconds. So if you're missing data for 10 seconds, that might be a problem. I'm just saying. All right, so those are the parts that make up the cluster. And the last thing we want to define when we're talking about a cluster is the fact that we have what is called quorum. Quorum defines the consensus that enough cluster members are available to provide the service. You see, a lot of people believe when you make a cluster, you're saying, now I want to keep this service up in perpetuity. That's not really the case. The idea with a cluster is, if I lose one or two things, I'm going to keep the cluster services provided. I want to keep things going. If I have a catastrophic failure, it's better for me not to offer the service and protect what I have so that I can bring it up later somewhere else or repair the catastrophic issue than it is for me to risk having the system out there. For years, it was 50%, and that's still the same. If you've lost more than 50% of the original membership of the quorum, then the quorum will say, you know what, I'm not going to risk the service getting corrupted. I'm going to stop providing the service. And in order to get that, every node that we put inside of a cluster, every server we put in the cluster gets a vote. The ideal quorum is we want odd number of votes. So if you put in an even number of machines, let's say I just make a very simple 2-node cluster, I would then create a file share witness, which would be a shared folder that's on another server that the servers could see and interact with. Or I would dedicate a shared disk between those machines. If I have an odd number of computers in the cluster or nodes in the cluster, then I don't have to worry about a file share witness or a shared disk to have a vote. But the idea is we keep the service going as long as more than 50% of the votes are there. And that's the way it's always been with quorum. And with the mode that you chose, like I said, node majority, only the nodes have a vote. Node and disk majority, all the nodes have a vote, and a disk witness has a vote. Node and share majority, everybody has a vote, including a file share witness. Then we had the last one here, the no majority disk only. Now that node right there, that was the one where we said as administrator, to heck with protecting the service. I want this to stay up as long as a shared disk is available. So if there's even one node remaining out of a 16-node cluster, if one is remaining, keep the service going on that one node. We're sacrificing the, we're making a calculated risk here, saying that, well, I've lost 15 of the 16 votes, something bad must be going on, but by golly, I'm going to keep this service running. Do we use this one all the time? No. There are situations where you might want to use a no majority disk only quorum model, but those are very specific requirements. The only thing that will take down a no majority disk only is if the shared disk in the quorum goes down, but you have to have a shared disk with no majority disk only. So how does this change? Those were the legacy concepts that we have. We still keep those. You can use them if you want to. Old quorum modes like no majority, no disk majority, no file share majority, you probably will no longer use them after you see how the new failover clustering works, but it's still there. Now, they do say it has been removed. No, they're still there. I've seen them. What we have now in Server 2012 R2 is dynamic quorum. This feature enables a cluster to recalculate quorum in the event that a server fails and still maintain working cluster roles even when the number of votes remaining in the cluster is less than 50%. In R2, dynamic quorum is further enhanced by the use of a dynamic witness, a witness disk or share that we can turn on and turn off as needed. When you configure a cluster in 2012 R2, dynamic quorum is selected by default, but witness votes are adjusted dynamically based on the number of voting nodes in the current cluster membership. So, for example, if a cluster had an odd number of votes in, the quorum witness doesn't get a vote. If the number of nodes is even, then the quorum witness gets a vote. If the witness resource or witness disk failed, or for some reason goes offline, which happens sometimes, the cluster sets the witness vote to a value of 0 automatically. But now by using this, the risk of a malfunction cluster or a malfunction cluster caused by a failing witness is reduced because we just say, oh, he's not there, he doesn't get a vote anymore. Take that vote away. So instead of saying like we had before, if I set up my server with 5 servers in it, 5 nodes, 5 is the quorum number, period. And every vote, every determination of 50% is based off the number 5. With dynamic quorum, that number is a variable. So I may start out with 5. If I lose one server in that 5, now I got 4 nodes. Well, the system says, oh, I got 4 nodes. I'm going to go turn on a witness disk. Now we've gone back up to 5 votes. Even though we've lost one machine in the cluster, we still now have 5 votes. If I lose another machine in the cluster, so now I've gone from 5 nodes in the cluster down to 3 nodes in the cluster. 3 is the odd number. Okay, so guess what? The dynamic disk turns off. The dynamic witness turns off. No longer gets a vote. Because now we got 3 going. So the idea is we keep turning this on and off, and we can keep going down below the 50% margin that we've had before. Now the witness vote does keep the system up and running. Keep it going even though we may go below 50%. And that is what keeps the system up and running, is this new dynamic model. So that is new. That is why this is the default, because this is designed to give you that leeway to possibly go below 50% of the original number, because the quorum dynamically changes the final number, the total votes, as it goes through. And that's the newest feature in Server 2012 R2 as far as the quorum modes go. I also mentioned that we have some changes in how clustered share volumes work. In a classic failover deployment, only a single node at a time controls the LUN. If I create a LUN and I put that LUN out there, only the primary, the active member of the cluster, gets control of that LUN. All the others, the passives in that cluster, could not see the shared storage until the active node released it. That meant that we had some longer downtime when a failover event occurred, because the active had to release the control of the LUN that it was using before any passive could take it over. Now, CSV was introduced in Server 2008 as a way to enable multiple machines to share a single LUN concurrently. Each node obtains exclusive access to individual files in the LUN instead of the whole LUN. That's the new concept. We break a LUN down, not the LUN itself, but the objects inside of it, the files inside of it. So CSVs provide a distributed file access solution so that multiple nodes in the cluster can access the same NTFS file system simultaneously. Now, that right there made them very popular with your virtual machine managers, with your virtual machine administrators, because this meant that I didn't have to make a LUN for each and every individual virtual machine that I had. I can make one LUN, format it as a CSV volume, and then each file, which would be the virtual machine files themselves, could be given to different host machines in order for them to run with it. So a single LUN could have multiple virtual machines on. That made better use of disk space. It meant that the resources in a single logical location could be all managed by multiple machines. There was no need to buy any special hardware to make this happen. And it gave me some increased resiliency, because CSVs have the ability to repair themselves. They have support for BitLocker. They have support for SMB 3.0. And a lot of other integration and resiliency functionality inside of them that made them a better choice than just using a LUN. Now, once R2 came along, they decided that, you know, we need to go a little bit further. Let's move this down and make this even better. And so with Server 2012 R2, we now have optimized placement policies. You know, in a failover cluster for Server 2012, one node in the cluster is designated as the coordinator for a CSV, and there's no automatic rebalance. In 2012 R2, CSV ownership is distributed evenly among all the nodes there. And that is performed based on the number of CSVs that each node owns. So the failover cluster service will automatically perform a rebalance in a scenario such as when a node rejoins a cluster or leaves a cluster, when you add a new machine to the cluster, whenever you have to restart or reboot a cluster, we can rebalance ourselves out. They've also made some changes again to the resiliency of CSVs. They have multiple instances now of the server service, which improves the resilience and scalability. We now have CSV cache allocation, which enables the server to use RAM memory as a cache for write-through operations, which is going to improve performance. We also have the ability to diagnose CSVs, and I'm not sure if diagnosability is a word or not, but it sounded good. And Microsoft uses it when they describe CSVs. In R2, you can now view the state of a CSV on a per-node basis. So you can see whether IOPS is direct or redirected, or whether a CSV is available or unavailable. And we can use PowerShell to look up that information. We also have interoperability. CSV now supports NTFS, of course. It supports the resilient file system, which is introduced in Server 2012. It supports the ability to do data deduplication, parity storage spaces, tiered storage spaces. You also have storage space write-back caching that CSVs can support, which wasn't available in the original release in 2012, but now is a function that you can do. Now, if you've never heard of storage spaces or anything like that, we got a class for you, just to let you know. That is 2012's new hotness, if you will. So that's the basics of failover clustering. So what do we need in order to be able to implement failover clustering? Well, Microsoft has some very key rules on failover clustering, what they will support and what they won't support. The first thing you need to know is the hardware. Whatever hardware you're going to use on the servers in the node, in order to be fully Microsoft certifiable, to be Microsoft serviceable, all your server hardware must be marked with the Certified for Windows Server 2012 logo. Now, does that mean I have to go out and buy all brand new stuff just so I can get a sticker on my chassis? No. It means you need to go and check Microsoft's website, TechNet, and make sure that your hardware is listed as certified for Server 2012. Also, just like with any cluster we create, the server nodes should be identical, as close as you could possibly make them to being identical to each other. If you can get the same hardware, the same firmware updates, the same everything, you are perfect for a server node cluster. And finally, we have to run the validate a configuration wizard. This wizard is the wizard that runs a series of tests against all the members of the node or all the computers you want to add into a failover cluster, and tells you what is the same between them, what's good, what's bad, what do you need to fix before you put this into production. Microsoft asks you to run that not only when you call for a service check, but also will ask you to do this as a troubleshooting step, because if you passed it originally and now you're not passing, let's see what's changed. The next thing you have to know about is the networking part. First off, your network hardware has to be marked with Certified for Windows Server 2012 logo. Again, look it up and check it out. Make sure that your hardware does that. The server should be connected to multiple networks. That way we have MPIO, multiple input output, or to a single network with redundant hardware. And that way we remove that single point of failure that can bring down the whole cluster. And finally, the network adapters, the actual NICs, they should be identical. Same manufacturer. They should have the same IP protocol, the same version, or same speeds, same duplex, same flow controls. Everything should be the same. If one of them has IPv6 enabled and the other one doesn't, one of them needs to have it either turned on or turned off, whichever one you choose. So we want them to be, again, as identical as we possibly can. Now, outside the machines and the environment itself, the infrastructure has some requirements as well. The nodes in the cluster must use DNS for name resolution. The servers in the cluster must be in the same Active Directory domain. And the user account that creates the cluster must have administrator rights unless you are doing the or administrative rights on that server. But they don't absolutely have to have the create computer object permission at the domain if you're using the detached mode of server 2012 R2. Remember, that one means that they don't have to be able to create that computer object. They create it, and everything is stored into DNS and locally on each member of the cluster. Some other recommendations: don't install or do not install the same roles on each cluster node. I'm not sure what they mean by that one. That might be a misprint on my slide here. Failover cluster infrastructure recommendation says that every node in the cluster should be exactly the same. Maybe you need to look at the second one. Do not install the Active Directory role. So actually this should say, and I'm going to just mark this real quick, do install the same roles. Identical. You want those machines. If they have file and print, one of them has file and print services role installed, the other one needs to have file and print services role installed. So make them as identical as you possibly can. As far as software goes, need to be running the same operating system, whether that is Server 2012 Standard Full or Server Core, or 2012 Data Center Full or Server Core installation. Notice that does say Server 2012 Standard. It used to be that you couldn't get failover clustering on the standard installation of the operating system. You always had to buy the data center or the enterprise level of the software. That has changed. You now can use standard. So you can buy the cheaper operating system and still get the ability to create a failover cluster. That's new. Now, all nodes must run the same processor architecture, 64-bit based, and all nodes should have the same service packs and updates. Again, make them as equal as you possibly can is the idea here with our clusters when we set them up. That really hasn't changed, that practice. So, real quick, let's talk a little bit about maintenance. What's new in maintenance? Backing up and restoring, and then a little bit more about that cluster aware updated. When you're backing up a failover cluster, some things that you need to keep in mind. There is a built-in backup that comes with every operating system. We're probably all familiar with Windows Server Backup. You can use the Windows Server Backup feature to back up your clusters. No problem with doing that. It doesn't have all the bells and whistles that some of the pay-for backup systems offer, but it still is a good system. You have to install this feature. It's not automatically installed for you. No problem. You go to your add roles and features. You go to your features section and add Windows Server Backup. The backups have to, regardless if you're using the built-in or if you're using a third party, it has to use Volume Shadow Copy Service as its backup engine. They have to be able to do that. And the Microsoft Windows backup system does use VSS. Make sure that your third party does as well. Now, what you also want to make sure that when you're backing up, you want to grab the system state backup. So when it brings up on the screen and says, what do you want to back up, make sure system state is checked because that has the configuration information for the cluster in it. If you have to do a restore from your backup, which we hope we never have to do, but we sometimes have to, you have two modes. You have the non-authoritative and the authoritative. Biggest difference between the two. If I have one member of the cluster that's having a problem and I repair that one, when I bring it back into the cluster, I want it to be non-authoritative. So when I restore that one node, put it back in the cluster, instead of telling all the other cluster members, hey, here's some information which might be old to them, he comes into the cluster and says, okay, catch me up to speed as to what's going on. Okay, great. Authoritative is when I take that, is used when the whole cluster is having a configuration problem. And I want to take every member of that cluster back to a point in time. So I take one node in that cluster, I install or do a restore a backup to that one server, put it back in the cluster and put it in authoritative mode where it says, okay, guys, hold on. You need to come get your information from me because I'm authoritative for this cluster. And now the other machines will come and grab their configuration off of that one machine. So non-authoritative, I've got one machine having a problem. Authoritative, everybody, the configuration is messed up and I need to fix all of them in one fell swoop. That's an authoritative. Those are your two big restore options. As far as maintaining them and keeping them up to date, the clusterware updating service, which is introduced in Server 2012, brings that to the table. It's an automated feature. It updates the nodes in the cluster with very little downtime. Instead of us having to go in here and plan, okay, I'm going to move these off of Server 1 to Server 2, then I'm going to do the updates on Server 1, then I'm going to reboot Server 1, then I'm going to take everything off Server 2 and put it on Server 1, and I'm going to do this to Server 2. No, clusterware updating automates this process. It does the updates for us. You can schedule it to pull the updates down. There's no downtime really because the system automatically balances itself out. So if it knows one server needs to be, or it's time to start doing back or updates, it starts going down the list and it says, okay, which one of you is the least busy right now? Okay, server number 3, you are. Let's evacuate everything off of you. I'm going to put you into maintenance mode, and then we're going to do our updates on you. And it works without us having to do very much intervention. In fact, we can have it set up where it is completely self-updating. In self-updating, we install the clusterware updating role on the cluster members. It becomes a part of the cluster itself. So there's no need to have this orchestrated out. The cluster runs its own show based off the schedule that we give it. If you're not really up to letting your system take care of itself, you want to have some administrative control, no problem. There's the remote updating mode. And in this one, we don't install the role on the cluster itself. We install it on another computer, which we'll call the orchestrator for clusterware updating. And then from external of the cluster, we can force the updates to start. That can be done as well. Either way, we can get clusterware updating going. And in fact, if you come back for the class on this, you actually get your hands on clusterware updating and get to see it in action. Now, I see we're getting close, short on time, so just one last thing here before we go. We're going to talk a little bit about multi-site failover. Now, in some scenarios, you might have to deploy a cluster where it expands across different sites. You've got a main site and you've got a disaster recovery site in most cases. Well, we have to look into things like our synchronization between the data because think about it. If I have a headquarters site and I have a DR site, they don't have a shared data between them. They don't have a shared storage. Each site has its own storage arrays. So we've got to make sure that the data in one is copied to the data in the other. We can either do that through synchronous replication, which means that the data is told to the host that it's completed writing only after both sites have reported in that they have written the data in successfully. So we have to wait for it to be committed to both databases before it continues on. Asynchronous is much faster. The host receives a write complete response from the primary storage after the data is written just to the primary storage. And then on a schedule, we have all the changes replicated to the second site. So with synchronous, we have a chance to be more up to date because we wait for the only thing slowing us down is latency, but we're continuously having communication across the media between the sites. With asynchronous, we pick when the updates happen, so we don't have that continuous communication across the WAN link. But if something should happen inside A, we're only as up to date inside B as the last replication took place. Those are the two choices that you have when setting these up. As far as quorum goes, when you're designing your quorum situation here, you can use, if you're still on 2012, you'd use node majority or node majority will file share witness. You would want the file share witness to be in a separate site than the two sites in the cluster. That way, even if something happened and knocked out the primary data center, the file share witness may stay up. You also have the option to use what's called an alternate file share witness, where you, if one file share witness is down, we'll go to an alternate and ask it for a vote, but it's only called when the original is down. So you might have a file share witness in both the headquarters site and in the DR site, let's just say. And the DR site would be the secondary. So if the headquarters is down, that's the only time the alternate's checked. In 2012 R2, dynamic quorum takes care of it for you. And like I said, you need 3 locations, one for the headquarters site, one for the DR site, and one to be your file share witness. So that's the best practice. Not always something we can do, but that's why alternate file share witnesses were created. Whenever you do a multi-site, you need to ensure that the business requirements are met by the solution. You don't want to go overboard, but you don't want to miss business requirements. You also should use a hardware vendor to make sure that both hardware in both sites is exactly the same. Make sure you have your quorum model set properly to maintain functionality in the case an event happens where you have downtime between the headquarters site and the DR site. We can bring the DR site up manually if we have to. And also make sure you're either you're using the right synchronization, either synchronous or asynchronous, to meet the needs of the business. That's the biggest thing to keep in mind. All right. Now, if this 45 minutes of information is something that you think that would be highly beneficial to you to learn about, this all came from Patch 2417D from Microsoft. This is the latest version. This is the upgrade exam. This is the one that gets you if you have your MCS E on Server 2008. This one will take you right up or help get you to the MCS A on Server 2012 R2 or Server 2012 itself. So this is the latest. It just came out here recently, like within the past month. But it's chock full of very useful information. In fact, I recommend this to people who may not be looking for exams, but is looking for information on what's new with 2012 because you've just gone out and you purchased 2012. So if you're interested in this, get with an account executive, account representative, and see about finding more information on this. And like I said before, custom classes are also available in case you need just particular information from Microsoft. So now I'm going to open the floor back up to Q&A for a few minutes. I've got a couple of minutes left, and then I'm going to have to go, but I'm going to turn this back over to Andrew.
So, no worries. So we have a couple questions, and like Jason was saying, we have 5 minutes of questions just because he's teaching a class today and he needs to go eat some lunch beforehand. But we have one question here that's saying, are SANs required? And it's from Eric, and I'm assuming that was a specific question, or that might be general.
A SAN is not necessarily required. A SAN is very useful because, of course, the speed it has. But you can use failover clustering as long as there's some sort of shared data between the nodes in the cluster. Then you can get by without a SAN. You can use an iSCSI network storage device. You can use directly attached storage, where you have a very cheap little box that you've purchased. We used to have this at New Horizons. It had 5 bays inside of it, 5 hard drives, and it had 2 adapters coming off the back of it, one plugged into one machine, one plugged into the other, and that was a shared data between them. And so that was a cheaper alternative. We didn't have a SAN here at the Nashville office, so that worked out perfectly. But with iSCSI, if you're looking for something that's fast, but you may not have the capital investment to go with a fiber channel SAN, iSCSI is going to be perfect for working with this. And then if you're in multi-sites, it really depends on what the sites offer themselves, and the same rules apply on the storage. All right. Any more questions?
So I have a question. Is this session being recorded? And the answer is yes, it is. And it'll be up on YouTube hopefully by the end of the day. If not by the end of the day, by the end of tomorrow. It's youtube.com/NHUnited. So if there aren't any other questions, we can go ahead and call this a day. I want to thank everyone for coming out. Really appreciate your attendance, and thank you to Jason for a great presentation.
Well, thank you all for attending and giving me a chance to let you know a little bit more about failover clustering. Hope to see you in a class in the future.